Now we will solve some oblique triangles. And in each problem, we will look at this case when we have two sides, one angle. That means we're given two sides and one angle of an oblique triangle. Can we possibly solve it? And I'll give you a few examples. So the first one, you can see this is a ABC, and we're given the side A and B, right? So here, A and B, and also angle B, capital B. So you see, side angle. Yeah, side angle. So here's the side angle. And then that's all we know. And then we want to solve the triangle. That is, if there is a triangle with the side length given 2.89, 4.24, and B, the measure for the angle B is 60.34 degrees. Can we solve this triangle? So what is the other two angles, right? If there is such a triangle, then we're supposed to find the unknown angles because there are two unknown angles, A and C, are to be found. Also, one unknown side is to be found. So this is C. What is this? What is the angle A and C? Capital C. So let's go ahead, try to solve it if there's a solution. So using the law of sines, we naturally think, okay, we have two sides and this, then we immediately think of this B. Okay, you see, you have the capital B, you have the lower B, you have the lower A, and all we want is to find the capital A, right? So let's write this capital A. So let's write our law of sine in this way. So the only thing unknown is this, because you can immediately check. You see the B, capital B, and lower A, everything. So this is an equation that we can use. We can use to find capital A. So let's multiply both sides by A, the lowercase a. So if we multiply both sides by A, then you see you multiply both sides by A, right? You get a new equation. So this is to get sine capital A on one side, just isolate. So we have only sine A on one side of the equation. The other side will become A times the sine B over B. So we are ready to get sine A. So what is the value A given, right? You put a 4.24 here. And what is the capital B? B is also given 60.34 degrees. And then you take a calculation of sine of 60.34 degrees. And what is the B? B is also given as 2.89. So we put all these numbers, then we can find sine A. So let's go ahead, decide the sine A. So this is our equation. And then we put all the numbers in. So this is a lowercase a and lowercase b. This is a sine of capital B, everything in the put in the equation except this A, right? Capital A, the angle is unknown. So we have this equation, we solve for the sine A. And then we discover the sine A is, if we keep 4 decimal places, it is a number which is bigger than 1. So we know it is impossible for sine function to have a value bigger than 1. So therefore, we cannot find such an A, the angle A, no matter it is acute or obtuse angle. There's no such an angle whose sine value is bigger than 1. So no solution. So we cannot possibly find an angle for this triangle which has which will satisfy this condition. So that is easy to see it, because if we look at the graph showing that we have this length, there's another side length, there's the angle. So that shows that it's impossible to form a triangle with this side length and with that set of information. So it's impossible because this will not be a reasonable length to generate an angle A. So we just saw one situation, which is a side angle. And we're given side angle, but there's no solution for this problem. So next example, we will still look at a side angle. So this is another problem we're given again side angle. So let's see, this time we know the BC, 2 sides, and capital C angle. So let's see the picture. The picture shows that we know the C and the B and this angle. So again, side angle, side angle. So this is a side angle given, and we want to decide the third side. Yeah, so the only side that is unknown is A. That is a side to be found. Well, what else? And we have 2 angles to be determined. So this is the angle A, angle B also to be found. So to solve this triangle means we want to decide the side length A and angle B and angle A. Okay, keep that in mind. So let's see which one to find first, right? So think of the law of sines. Think of the law of sines, and because this C and this C, then immediately we can think of sine capital C over C. And then this B, for example, capital B is unknown. So we can possibly find capital B because sine capital B over B. So in this equation, the only thing unknown is this part, sine B. Everything else, you see, C, capital C given, lower B given. So then we can quickly find what is the sine B that can be found, right? This is immediately to be found to be B. We multiply both sides of the equation by B times sine capital C over C. Then we can find sine B. Then once we get sine B, we can find the B, capital B. So once you get the sine value of this, then we can try to discover what B is. That's right. So then just to put the numbers, then we can solve. So you can also do, okay, so if you think, how about A? That's the same. But A is not known yet, right? Capital A is not given. This lower A is not given. So we have two unknowns. We don't want to touch this yet, not yet. So let's find B. So it's very natural to find capital B. So here is the process of finding the capital B. So here is the law of science that relates the capital B and capital C and lower b and lower c. So in this equation, we know everything except this capital B, right? So let's solve. And after you put all the numbers in, you can see we know everything else except the capital B. So the sign B will be found. As you can see, this right-hand side, right? You can see the right-hand side. If we multiply it by the 4.68, and we get sign B. So after you do the calculation, and these are decimals and not special angles, you just use a calculator and then you get approximately 0.6721 if we keep 4 decimal places. So this B, whose sign value is 0.6721. So we know that the capital B can be an acute angle, so if you look using the sine inverse, right, you will get sine inverse of 0.6721. With your calculator, this sine inverse will return an acute angle, which is approximately 42.23 degrees. So that's one possibility. So by doing this, we get an acute angle. But also we know that B could be an angle that's larger than 90 degrees, less than 180, because it's an interior angle of a triangle. So it has to be less than 180. So that means it's possible it is obtuse. So that has the same sign value. Then we find the alternative, the other possibility for B, capital B, is 180 minus 42.23 degrees. And then that will be 137.77 degrees. So we have two possibilities. One is that capital B is acute, is an acute angle. The other, it is the angle that is supplement of 42.23. So obtuse angle. So with the two possibilities, let's take, so suppose it's the first case, then we can immediately find another unknown angle. So let's find A. The third, one more unknown angle once we get B, right? So we just use 180 minus B minus the given angle C. Then we will get a solution for A, which is also acute. So when this B, we take that possibility when B is acute, then we find A is 85.06 degrees. But certainly when B is the obtuse, then you put another possible value of B, then you can find another possible value for A as well. So then we can discover two possible values for A, depending what B value is, what this capital B is. So we can look at so we get two possible values of A, and now we're ready to solve for the remaining side because there's still, if we look at the picture again, okay, so this B, do we have capital B? Okay, yes, we actually when this B is obtuse, let's see, it's actually impossible. This one why we discovered that it is impossible for B to be obtuse because given C, right? The C is given as 52 degrees. If we add this B to that C, already it's over 180 degrees, which is impossible. So if these two angles together it's already more than 180 degrees, then what is the possible value for A? So the A cannot be negative. So that exclude the possibility, that will exclude the possibility for B being obtuse. Because if that is the case, then you can try to find A, which is 180 degrees, minus this B, which is 137.77 degrees, minus what? C. C is 52 given, right? 52.71 degrees. Then if these two together is already more than 180, then A would be negative. That's impossible. So we see this is not possible. So then we have only one case, that is A is 85.06 degrees. We don't have two cases. Now then, what is remaining? It is we have found, right? B, we have found A, two unknown angles. Now we're done because the C was given. So we only need to find one more side. That is the A, because in the problem, the side A was not given. See the side A. The side A is the side opposite to angle A. That is not given. So we're trying to solve for A. So then it is immediately to, we need to do this equation, A over sine A. And now we have options. Which one do we choose? We use B over sine B, right? That's the law of sine. Or do we use C over sine C on the right-hand side? So although we have options, I prefer to use C over sine C instead of this one. I want to use C over sine capital C. Why? Why do I prefer this one? Because there's nothing wrong to use this first one. The reason is that B is given. You see, B is a given. But the capital B is something we found through our calculation, right? If in case you made a mistake somewhere in the calculation of capital B, then that will impact your answer for A. So we try not to get some additional error if in case B is wrong during our own calculation, then we don't want that to affect our results for A, for this lowercase a. So it's so now we use the C over sine C. Okay, so let's put a C over sine C because C is given, capital C is also given, so all given as whatever assumed, right, to be true for the triangle. So now we have all this, then we're ready to calculate A. That's the last thing we need to find. So the lowercase a is to multiply both sides by sine A. So we multiply both sides by sine A. So the right-hand side is C over sine capital C. And then it's being multiplied by sine A, then to find the lowercase a. So remember, we just got the A, right? Also the C and capital C are given. So everything given, so we can determine the lowercase a. So here by solving this equation, and we get lowercase a. Yeah, so as you can see in this equation, everything already is known except the a. So we isolate a, and finally we get the value a as approximately 6.94. So now we have found all the unknown angles and the unknown side of the triangle. So we solved this triangle, which is also side angle case, but we have found a unique solution. We have found a unique solution. So all the unknown sides are determined and unknown angles. So the next case, also side angle case. In this example, if we take a look at this, we have a side angle, right? Side angle. So again, we're given B, C, and capital B. So this is a side angle. Let's look at, here is a B, C, see, side angle. Yeah, of course, from the figure, we see two possibilities. So how about side angle, the same side length, right, can lead to two different triangles, side angle. So with the same data, we can have one triangle. See this side is the given angle. We can have one triangle, and you can possibly get this one, side, same angle, right? Triangle. So you see, two different triangles. That means this situation, side angle, can lead to two solutions when we solve the triangle. Let's actually discover how to solve the triangle. So with the given information, B, C, capital B. Okay, so the B is a 6.11, C is 8.52, capital B is 29.08. So if we write an equation, what do we want to solve first? It seems B over sine B, C over sine C, that is the C, right? The angle capital C is to be found. So let's write our equation, capital C, because capital C is something we want to find. So we put it, suppose just like in the convenient form, we put it in the numerator over C. Every C is lowercase c given and lowercase b given, sine capital B given. See, in this equation, except capital C, everything else given. You see the capital B, lower b, and lower c, all given. Only the capital C is to be found, this C. So we solve this equation, we can find capital C, right? As long as we multiply both sides by lower c. So the right-hand side multiplies lower c. And then we can find sine capital C. So all you need is to plug in numbers. So you see this B is 6.11. The C is 8.52. The capital B is 29.08. So we put numbers in, we can get sine capital C. And then we will determine what C is. C is the angle. So you see, after we get specific numbers, we find the sine C is 0.6777, right? Approximately 0.6777. And we look for the capital C. If sine C is this, then capital C could be sine inverse of this number. Sine inverse, it will return an acute angle. So we can discover it is 42.66 degrees. So that's one possible value of C. The other possible value is the supplement of 42.66. So 180 degree minus that. So this is an angle that is in the second quadrant. Remember, whose sine value is also positive. So it's immediately another possibility for C. So we can have either an acute angle or an obtuse angle, and their sine value will be the same. So then we have two possibilities for C. So if it's the first possibility, when the C is acute, then we can go ahead, look for A. So the A, when the C is an acute angle, A will be 180 minus B minus this acute angle, right? 180 minus the B, which is given, 29.08. And minus this acute angle, we get a possible value for A. So that is the A when C is acute. Yeah, when C is acute, we can get the angle A as an obtuse angle. And another possibility is when C is obtuse, when C is more than 90 degrees, and then we can find an A which is acute. So if we show that in the figure, you can just take a quick look at our previous work. So once we get C, two possible values of C. So one case is that C is this one, acute. The other possibility is the C as obtuse, right? When C is an acute angle, then A will be obtuse here. A is 180 minus the B and this C acute angle, then we can find the A, which is obtuse. But when C is obtuse, then we can find A, which is a acute angle. So then we see the two different triangles. So depending on which C value, right? The C value will decide what A angle is. Okay, after that, what is still to be found? And we still have to find the A. Suppose A is an acute angle, then what is the length A? Right, this to be found. If A is that bigger obtuse angle, what is the length A? Then that will be this case. So we still need to find the length A based on the each case. Okay, that's what we are going to do in the following. So the length A, immediately we choose the law of sine in this version. This is we put A, the length A to be found right in the numerator just for the convenience. A over sine A equals B over sine B. You see the choice of B over sine B only because this B is not the or capital B, right? Neither one is a value calculated by us, because we try to use whatever is given. That way, they are given values. If possible, just use what is given. But of course, you can use C over sine capital C, because as of now, we have found capital C, right? When C1 and its corresponding C is given. So we have found, but we don't want to use it because the capital C, so we try to minimize the chance of leading to new mistakes in case our calculations mistake. So we use what is given here, and this A, of course, we have to use capital A, right? That's a result from our calculation. So the A1, when the case A, the angle is obtuse, then we will find a length. So we solve this equation, find a length, which is 11.94. And next, we have to solve same equation when the corresponding angle A is an acute angle. So then we can find a length, A2, which is a shorter A. So 2.95. So after we have solved, then we can see we have found two solutions. That means two possible triangles that satisfy the side angle. So we are given side angle, and then we found one of the two solutions is this one. This with C1, right, to be acute, and A1 to be obtuse, and this A1, the length A1 as 11.94. So that's one solution. The other solution with the given side angle with the given side angle, and the way we found it's also possible that the C to be obtuse, and then this A, that's a second triangle, so we label this C as C2 with a subscript. That's another solution. We call C2 A2. That's corresponding to this angle C. Then we can get the A2, which is smaller. And then this side length A2. It is the side length corresponding to this angle. So we adopt different notations just to say this is our second solution. So you see an example with the side angle given. Then we found two solutions in this problem. So far you have seen three examples. The first case, no solution. The second case, one solution. This is the third case, two solutions. So here, two solutions, right? We see both. And then the previous example, we found one solution. That is, there was one unique triangle that satisfied the side angle data. And the very first example, we couldn't find a solution at all. So no solution with the given side angle information. There's no such a triangle that with that side length and such a given angle. It's impossible to find a triangle. So no solution. So this a side angle case is called ambiguous. That means sometimes you have zero solution, sometimes you have only one solution, sometimes you have even two solutions. So not yeah, so depending on the situation. So that's why it's not always guaranteed you can find a unique solution. That's why side angle case is called ambiguous case.